All right, let's begin. I'm Jessica Philippe, the Member Engagement Librarian at SCRLC. Today's program is the third in a series that we're hosting on preparing for the April 8th total solar eclipse. This series is supported in part by the American Astronomical Society's J.M. Pasakoff Solar Eclipse Mini Grants program. So we're here to learn about safe solar eclipse viewing and photography, and joining us is Phil Harrington, who is an astronomy author and educator. So welcome, Phil.
Thank you very much, Jessica. Hi, everybody. I appreciate being asked to discuss a topic that has been near and dear to my heart now since I first got involved in astronomy as a middle school kid way back in 1968. My first solar eclipse, not a total, it was a very deep partial, as they say, was back in March of 1970. And I really caught the bug, eclipse bug, back then. Between that and lunar eclipses as well, I just love viewing eclipses, and I've viewed as many as I possibly can. Partial eclipses, total eclipses. Talk about all the mechanics in a moment, just by a quick review. But the topic today is, I think, a very important one because, well, in a matter of weeks, we're going to view a true spectacle. Now, in upstate New York, you all are going to have a much better view than we would here on Long Island, but that's because I'm going to be joining you. I'm going to be driving. My family and I, and as well as friends and relatives, are going to convene just outside of Buffalo to view the eclipse, just praying to the weather gods that we get good conditions. But we're really looking forward to it. So it's going to be just a spectacular event, spectacular vacation, and something that I hope everybody here gets a chance to enjoy. So some tips for safe viewing and photography is the order of the business today. Quick though, and I know the last couple of talks in the series talked about this also, but I just want to go over it very quickly for those who may not have seen those two. What's going on with an eclipse of the sun? Well, an eclipse of the sun can only take place when the moon, as it goes through a series of phases, when the moon is hang on, I just had something pop up on my screen, which I don't want to see. There that goes. When the moon is at the new moon phase, that's when it's located almost directly between Earth and sun, like you see right there. Well, normally, because the Earth, as the moon orbits the Earth, the orbit of the moon is tilted about 5 degrees with respect to the orbit of the Earth around the sun. And as a result, because the moon is only a half a degree across in our sky, as a result, the shadow of the moon, which you see here is being cast onto the Earth's surface, normally the shadow of the moon misses Earth. But every now and then they line up perfectly, what's referred to as a node in the orbit of the moon. It crosses the Earth's orbit of the sun exactly at the moon. When that happens, the shadow of the moon is cast onto the Earth's surface. Now, as luck would have it, the moon is 400 times smaller, almost exactly 400 times smaller than the sun, but it's also almost exactly 400 times closer to us than the sun. And as a result, the moon and the sun appear to cover the exact same apparent size in the sky, about half a degree, about half a degree. And so if they line up perfectly at the new moon phase, the silhouette of the moon slips over and completely blocks the sun's visible surface, which they call the photosphere. When this happens, you have a total eclipse. The shadow of the moon that you see, if you can see my cursor here, hopefully, the shadow of the moon casts down to a very nearly a point right over here on the Earth's surface. That's the darker central shadow of the moon. It's called the umbra. Well, if you're standing under the umbra where an eclipse occurs, you're going to see what the picture is at the upper left-hand corner. You're going to see the silhouette of the moon, which is the dark circle, completely blocking the sun's visible surface, the sun's photosphere. When that happens, outer layers of the sun, outer layers that are normally too tenuous, too thin to be visible because the sun's light overwhelms them. But when you block that overwhelming sunlight from the photosphere, we have the outer layer, an outer layer called the chromosphere appear, a really beautiful deep red color. And then beyond that, the outermost layer of the sun, referred to sometimes as its atmosphere, is called a corona. Corona. It looks like a blossom around the sun. You'll see that total eclipse. Well, if you're somewhere inside the outer gray shadow that I have labeled here as the penumbra, you're going to see a partial eclipse. like I have in the picture at the upper right. Okay? Only part of the sun is going to be covered by the moon. Well, as luck would have it, on April 8th of this year, the shadow of the moon, the central shadow of the moon, is going to trace right across the U.S., crossing the Rio Grande River from Mexico into Texas, pretty close to San Antonio. It's going to keep on going diagonally up to the north and east, going to cross over portions of Illinois, Pennsylvania, and New York before it goes into northern New England, ultimately into the maritime provinces of Canada. If you're on that line, that thin line, the line where the shadow of the moon almost comes to a focus, you'll see a total solar eclipse. Well, speaking of solar eclipses, here are all the total solar eclipses that will take place crossing the US and Canada and Mexico in the 21st century. Well, you'll see that the last one occurred August 21st, 2017. Okay, it was the first total solar eclipse to cross the continental US since 1979. So we had a real gap of nearly 40 years for total eclipses across the U.S. But then we had that in August 2017. I wonder if any of you may have gone to that. And my family and I, we traveled down to Tennessee to see that, and it was just amazing, an amazing journey. Well, you see that went from the Pacific Northwest diagonally to the southeast across the U.S. Take a look at April 8th, 2024, where it's going from the southwest, it's going up toward the northeast. And they crisscross right here in Illinois. Well, for us here in 2024, it's going to follow a path that's going to, as you can see over here, go right along the U.S.-Canada border, pretty much right across New York State, then up into Vermont, New Hampshire, Maine, and so on. This is the 2017 path that you see. And as I mentioned, we took a trip down, we drove down to Clarksville, Tennessee. It was wonderful. My daughter did an amazing job laying out the route. We saw all sorts of wonderful attractions along the way, as well as coming back home again. It was really a trip of a lifetime. And we've gone on a number of vacations, which I've loved, but this one really stood out in my mind for the eclipse, certainly, but also for everything we saw along the way. Here we are set up with a group of friends from Massachusetts, New York. Where else were they from? Connecticut, I guess, also. But we were all set up directly adjacent to our hotel. We didn't have to go anywhere. And as you can see, the sky was nearly picture perfect. This was my setup. I had two cameras running. One on the left there, on a small telescope, and the other one on the right was a telephoto lens. And I got some really astonishing photos with this. Here we have the eclipse just beginning, and if you have a good eye, you can maybe see just a little flattening right here. That's just as the silhouetted edge of the moon just kissed the edge of the sun. Well, you keep on coming back, and more of the sun is being covered. And before you know it, here's totality with the corona blossoming. You can see all these layers and lines in the corona. These are the result of the sun's magnetic field twisting and contorting the material in the corona. It's referred to as plasma, heated gas, but heated gas with certain properties that make it electronically conductive. So it's called plasma. A shorter exposure, you can see still some of the inner corona, but now along the edges, you can see what are referred to as prominences, these huge flame-like structures billowing up from the sun, again, indicating areas of extreme disturbances in the sun's magnetic field. A closer up view of one, for instance. This particular prominence that you see right over here, many times the size of the Earth, to give you a feel for the scale of what we're looking at here. Again, the prominence is another couple blossoming over here as well. But before you know it, it starts to get bright again, and the sun's light just begins to peek out from behind the very rough silhouette of the moon with mountains and valleys and so forth, breaking through, resulting in an effect they call Bailey's beads. And then before you know it, the eclipse is over. Only a matter of minutes. That particular one was about 2.5 minutes. And it was the fastest 2.5 minutes of my life. But we had just a wonderful experience. And so that's why literally the day after that eclipse ended, we were already thinking, okay, where are we going in 2024? Well, here's the path that the eclipse will be following that Monday. You see all the cities that it passes through. I don't know the numbers, but I'm going to suspect that this particular eclipse is going to go over a greater segment of the population than the one in 2017, just because of the major cities, especially those in the Northeast, that it'll be going over. And of course, here we are. Look at that, three major cities in upstate New York: Syracuse, Rochester, Buffalo, but others as well, Watertown, for instance, and so forth. Um, Going to be just a wonderful opportunity to view this given good weather. Well, of course, that's always the trick. Is it going to be good weather? Well, you can look at climatological data and records and so forth, and that's what I have here. And you can see sort of a profile of averages, And the scale on the bottom over here, this is for April, all of April, not just April 8th, but all of April. You can see that the best opportunity to see an eclipse would be in a blue segment, but take a look at the path, there is no blue segment. So in other words, there is no free lunch. You can't say, oh, I'm going there to be guaranteed clear skies. No, the best you can get are in the grays over here. And you can see that portions of Arkansas, a little bit of Oklahoma here, northern Texas as well, seem to be pretty good. We get into a little bit darker coloring here across Indianapolis and so forth. Ohio looks like a problem, Cleveland, for instance. So does Pennsylvania. But although you can't see it quite at this scale, the portion right around Buffalo and Rochester seems to be especially favorable. It drops off a little bit as you get towards Syracuse. And then as you go across into the Adirondacks, the higher elevation of the Adirondacks, that's when the odds of clouds actually go up. Okay. And likewise, you go across northern New England, the odds of clouds go up as well. So again, there's no guarantee, but those seem to be at least better odds. Okay, better odds.
Phil, we
But
have a
how have
question
things
in the
looked?
chat. Just if you go back
Oh,
one
yeah, sure.
slide, just the numbers there in that key. We're just wondering
Sorry.
the numbers in the
Let's go
key.
back to them. Here we are here. Okay.
Yeah, is that
Number,
related to the cloud cover then?
yeah, it's the number of days. The
Days.
number of days. Yeah, number
Okay,
of
got
days.
it.
I should say that. Yeah, number of days when it's cloudy. So less than 4.5 for the blue and over 20.4 for the red. Thank goodness there's no red along the way here. But you can see here, it's somewhere in the 13 to 15 or so day range out of the month. So that's about 50%, I think is how you would interpret that, given the 30 days in April.
Okay, thank you.
Okay, sure. Here we have the path itself that's going to see, and you can see the cities that's going to go over. Here's Buffalo, Niagara Falls, Jamestown as well. Anywhere in the shaded area, you will see a total eclipse. You want to get as close to the center line as possible if you're like me, a glutton for this. You want to get maximum effect because the closer you are to the edge, say in Syracuse, they'll see a total eclipse, but it won't last as long as, say, the folks in Buffalo or Rochester or Watertown or Plattsburgh over here, for that matter. The closer you are to the blue, the better off you are. Here's some timeline for the towns. You see Jamestown, for instance, begins a little after 2. That's when the partial eclipse begins. Total eclipse will begin at 3:17. But you'll notice it's not even 3 minutes long. Whereas you go to Buffalo, it's going to begin at 3:18, but 3:22. Okay, well that's a little closer to 4 minutes long. The maximum, the total phase of a solar eclipse can last, not this one, but I'm saying maximum possible, is 7.5 minutes. 7.5 minutes. It's usually a lot less than that. This one is better than the one in 2017. Right? I saw one in 1991 down in Baja California, the peninsula in Mexico, south of San Diego. We were due to have 6 minutes and 57 seconds of totality. Wouldn't you know where we were set up? It was downwind from a fairly high range of mountains. And when everything started to drop, the temperature drops, can drop upwards to 15 degrees during totality. Everything gets really dark. You end up with a bright glow around the horizon. It looks like a 360-degree sunset glow. It's really astonishing because the shadow is right on top of you. But that causes the air temperature to drop. And what happens when air temperature drops? Humidity goes up. Water condenses in the atmosphere. Humidity goes up. Clouds form. Sure enough, the clouds went right over my observing site. And instead of 6 minutes and 57 seconds, we had about 3.5 minutes or so. We were clouded out midway through totality. Anyway, stuff happens. But this is the path somewhere you want to be. And note again the times as we go. So it's going to be a mid-afternoon event for the entire state. Is it going to be clear? Well, we can look back the last few years. In 2018, Here we are in Buffalo, for instance, and you can see that it was clear in upstate New York. But again, as you go more toward the Adirondacks and then toward Vermont and New Hampshire, you see how the clouds gathered over here? And again, Ohio, Indiana would have been completely socked in. We go to 2022, and you see again, Buffalo was reasonably clear. So was Rochester, even clearer. But once again, northeastern New York and into Vermont and so forth, clouded out. Texas, of course, would have had a beautiful view. How about just last year? Well, last year, Texas actually had some clouds. Okay, as you can see here, New York, almost the entire path through New York was cloud free. So you never know, right? You never know. A friend of mine, Joe Rayo, who's a meteorologist and a devout eclipse chaser as well, he made a statement once which really stuck with me. Climatology, which is what we're looking at with these records, climatology is what you expect, but weather is what you get. And that's true. It can change literally minute to minute. So you never know. Okay, we can only hope for the best. Well, let me just look real quick in the chat room. I saw some activities here. Okay, we talked about the figures. Okay, I guess we're good. How to watch the eclipse safely. The sun does have a unique feature. It is the only celestial object that can do you physical harm. Okay, let me talk a little bit about that. Okay, because there's a lot of myths about this. Okay, a lot of people are under the impression that for some reason a solar eclipse, sun's rays during a solar eclipse take on some sort of a mystical evil property. They do not. They do not. The hazard, if that's the word I want to use, and the cautions that must be used, same as any clear sunny day. There's nothing magical or mystical about a solar eclipse. Okay, that's number one. Number two, the brightness of the sun, it may give you a headache, but that's not what's going to do you damage. The visible light from the sun's not going to do you damage. What's going to do your eyes damage, what you can't see. Ultraviolet radiation, infrared radiation, the same radiation from the sun that causes your skin to burn in half hour, 45 minutes, will burn the retina of your eye permanent damage in about 30 seconds. Okay, the retina is much more sensitive to this than your skin is. About 30 seconds. And so therefore, you don't want to stare at the sun. Okay, plain and simple, without proper precautions. But once you put those proper precautions into place, you can stare at the sun from sunrise to sunset every day of your life, and your vision will stay just as good as it was if you hadn't done it at all. Okay, the precautions, thankfully, are very easy. Okay, very, very simple. And so I want to talk about some of that to put might be some concerns. I want to put that to rest. Okay, there are different ways to view the sun. To talk about maybe the most popular way, I want to go through a series of, I liked Charlie Brown growing up, the Peanuts comic strip. I just loved it. Well, back in 1963, there was, in July of that year, there was an eclipse of the sun, total eclipse. It was going to go right across Maine. It's going to go mostly over Canada, but it was going to cross Maine. And of course, it caught a lot of attention back then, to the point that the cartoonist Charles Schulz, who authored Peanuts starting in 1950, he had a week-long series featuring Charlie Brown on the left and his buddy Linus on the right. Now, Linus was always viewed as the smartest kid in the group. He was the one with the security blanket and sucked his thumb, but he was always the smartest kid in the group. And so the first panel in the week-long panel shows Charlie Brown saying, "I hear there's going to be an eclipse of the sun this Saturday." Linus says, "Yes, but my ophthalmologist says it's very dangerous to look at." Charlie Brown says, "Well, I planned to use sunglasses." Linus appropriately cautions, "Don't do it, don't do it." Sunglasses, smoke glass, photographic negatives, even welder's glasses aren't safe for directly viewing an eclipse, and that's true. Charlie Brown says, "How would your ophthalmologist feel if I closed my curtains and stayed in bed all day?" That's often people's reaction. When we were going to an eclipse, I saw an eclipse in 1984 in North Carolina, and I was driving down with a friend of mine. We heard on the news down there that from outside, we were outside Charlotte, somebody said, "Oh, don't let your kids go outside today. The eclipse is going to hurt them." And I'm just banging my head against the wall, in my car, the window of my car, because that's not true. And the children had missed a wonderful opportunity, wonderful learning opportunity. So let's go on. Lucy, Linus' sister in the middle, is Schroeder. on the left-hand side. Lucy asks, "What are you doing?" Linus says, "This is a projector for observing the eclipse tomorrow." There's no safe method for looking directly at an eclipse. Not true, but I'll clarify that. That was true maybe in 1963 when this came out, but not today. And it's especially dangerous when it is a total eclipse, and that's also not true. Okay, so therefore we have a little scientific wavering here, but that's okay. We'll keep going. Therefore, I've taken two pieces of white cardboard and put a pinhole in one. This will serve to project the image onto the other board. See? Lucy says to Schroeder, "I bet Beethoven never would have thought of that." Well, here's what Linus created. It's a pinhole projector. Very simple. All you need are two pieces of cardboard. Okay? Make a pinhole in one that you see. And what you do during the eclipse, with your back to the sun, you hold the cardboard with the pinhole in it, hold the cardboard up towards your shoulder, the other one you have down below so that the sun casts its light through that hole onto the paper, and you'll see a very tiny image of the sun. It works really well. It's even better if you use, instead of two separate pieces of cardboard, use a cardboard box, because the box itself will serve as a shield to make the inside darker, and it'll make as you can see in the bottom picture over here, very tiny crest of the sun, make it easier to see. So you want a long cardboard box. You could use a tube also. You'll need scissors and duct tape. Aluminum foil is recommended. You put it along the top of the box like you see over here. Then you have the pinhole in it. Use a thumbtack, for instance. You can use a pin also. It's small. Okay, small is the point. Sharp knife or paper cutter is needed. A piece of white paper to put as the screen, and flat black paint to paint the inside of the box. That's optional. It helps a little bit, but it is optional. You're going to see as I go through these slides, I have different lists of items you'll need to make some of these and so forth. You don't have to write all this down. I put together a resource guide for all of this, which I sent to Mary Carroll yesterday, and she will distribute it to everybody on the call today. Okay, so you'll be able to get it that way. A better way of doing it, excuse me 1 minute, and what I used with my grandchildren back in 2017 is to make what's called a safe solar viewer. These are cool. Okay, these are cool. Terry Richardson, who was a emeritus facility at the College of Charleston, South Carolina, he was in the Department of Physics and Astronomy, came up with this idea. It's brilliant in its simplicity and ease of making. Okay, my grandson Jack there, who was only about 2.5 at the time, was pointing to the crescent sun to his sister Hannah, who was only about 1.5 years at the time, and now they're 7 and 8 years old respectively. So they're veterans of this already, but it works really well. Terry came up with two designs, and I wrote about them in the current issue of Astronomy Magazine, February issue of Astronomy Magazine. So if you happen to be able to get a copy of it, or as a matter of fact, it's online right now. The article, I mean, is online right now. And I believe I include a link to it in my resource guide. But I go through details of how to make both a simple safe solar viewer or simple SSV, and then an advanced SSV, which is what I made, what you see in the picture in the top left of my grandchildren. Both are very easy to make. The simple solar viewer will cost you $1.25. The advanced one will cost you about $7 or $8. Okay, so they're and the good news is very common products. Okay. Here's the simple version of it. You need a reading glass lens, just one. So if you go over to a dollar store, so you pay $1 for one of these reading glasses, or $1.25, let's say, around here, you need a long cardboard box. How long the cardboard box? It depends on the lens power or the diopter of the reading glasses. Now, Terry, the creator, recommends a 1.5 plus 1.5 diopter lens. You can use a +1 up to about a +2. The focal length, that is the distance from the lens to where the sun will come to a focus, the focal length is going to change, as you can see from this table. Right? And therefore, the length of the box is going to change, as you can see from the table as well. And the size of the image will change, as you can see from the table also. I'd recommend get a right in the middle, the 1.5, okay, the 1.5 diopter lens. That seems to work best. You'll need a long cardboard box, as I mentioned. Pretty thin, though. Okay, pretty thin. Scissors, binder, clips. I'll explain what these are for over here in a second. A knife or a razor, and a piece of white paper again for my projection screen over here. Now, if you're looking for a long box, this company online, it's called Uline, obviously. They sell cardboard boxes that would be perfect for these specifications. Unfortunately, because they're wholesalers, they sell them in bulk. You have to buy at least 25. Okay, so if I'm doing it as an individual, maybe I don't want to have 24 leftover boxes. But if you're doing it as a community activity, such as at a library or a school, for instance, be perfect for this sort of thing. You have everybody bring a lens, you supply the box, and some of the other items that you have over here are pretty common. And you could have a nice group activity for kids and their families to create this. It would take them, if it took them an hour, I'd be surprised. Okay, so again, I'll give you all this information, including the company name for the boxes in that resource guide as well. Moving forward, the box itself, you see, is open at the end, closed all the way around, but you have what's referred to as a focuser box over here. That's where the clips come into it. The idea is the focuser box is about 10 or 12 inches long. That's where the lens is attached to. So you cut the eyeglasses apart. You don't have to remove the lens from the frame necessarily. I mean, you could, but you don't have to. You hold the tape, you hold the lens in place with painter's tape, duct tape, whatever you have. This is not high science, but it works really well. You put it together, and this portion, the focuser box is called, slides in and out of the box while you have it aimed toward the sun. Again, the sun is here. Your back is to the sun. Okay, you want to look at the screen. You align it with the sun until the sun's image is projected onto the screen, and then you move the focuser box back and forth until you get a sharp focus. Once you get the sharp focus, put the clips in place, you're done. Just like that. Very, very simple. $1.25 for the lens. Okay, whatever the box and other items go. Well, that's the simple version of this, okay? And it works very, very well. It's not quite as sharp the image as you would get with the advanced version. Here we have the results. You see somebody's holding it such that the back and sun is to their back. There's a projected image here, and there's a view of what you would expect to see. Right? The advanced safe solar viewer, and this is the one I made back in 2017, does give you a brighter image and a sharper image. You can even see sunspots, these dark little spots on the sun that are storms or disturbances in the sun's magnetic field. You need two lenses. You need a lens in the front called the objective lens. This portion over here is the focuser, so you slide that back and forth on the base. The light then passes through a second lens to bring it to a focus on the screen right over here. Well, the lenses, you can purchase them from a place called Surplus Shed in Pennsylvania. Okay. Now, I'm not affiliated with them. I'm not promoting their product or any of these products I talk about this afternoon. This is just for informational purposes. But I picked up the first one, which is a single lens. Okay, it's their item number L14766, $5 plus $6 shipping. Interesting, shipping costs more than the item. But you get the single lens for the front, plus you get the Barlow lens. So all the optics you need for a total of $11. They have subsequently added two other options over here, and I give you information for both in the resource guide. I will tell you the cheapest one, the one that we used back 6 years ago now, 7 years ago now, works very well. Okay, would the other two get you better images? Yeah, they would. But is it worth the extra price and so forth? It's not a whole lot of money. It's not big money, certainly, but maybe. But I'm very happy with the first. Here's what you do. You pick up half-inch plywood to make the support rail, which is A. B is the focuser upright. Over here, that's where the front lens goes. The focuser foot, C, the two of them get nailed and glued together. Two guide rails, D, okay, over here, two guide rails. Those are that's a tongue depressor. I was at my doctor, and I said, hey, he used a tongue depressor on me to examine my throat. I said, hey, do you mind if I keep that? So I put it in my pocket. And I got my focuser guides just like that back in 2017. The Barlow upright is G over here. H is the projection screen. The guides are D, as I mentioned, that all comes together. E and F are a piece of cardboard actually to hold the lenses in place. And it worked together very well. That's how it all comes together. I include this photo, by the way, in the resource guide, and tells you what pieces go together where. And you see, to hold it up to aim it at the sun, what we use a laundry hamper from the hotel room. And again, it worked very, very well. Something else, which was mentioned in an earlier presentation here, NASA has a good guide how to make it. It's called a sun funnel. What you do is with your telescope, you can project the sun through your telescope, and with an eyepiece here, the image of the sun would go up through the funnel and would project onto essentially a rear projection screen over here. Another great way of doing it, absolutely. One caution I would give you here, though, if you're going to project an image of the sun through a telescope or, for that matter, a pair of binoculars, they're going to get hot. And an old telescope I had from way back in the day when I was a kid, literally some of the internal parts, which were plastic as opposed to metal, which they would have been with a better quality telescope, but some of the internal parts actually melted because of heat from the sun. Oops. So that's something you want to keep in mind. So if you are going to project the sun, it's for the partial phases now. Okay. If you're going to project the sun through a telescope or binoculars, I wouldn't necessarily do it for longer than maybe 10 minutes. Then I'd probably put something, maybe something as simple as a towel or a pillowcase over the front of the telescope just to block the light from going through, let everything cool off. And then you pull it away and you keep on going. But the sunfall is a great way to share the experience because now people can gather around my little rear projection screen over here at the mouth of the funnel, and everybody can see what's going on. Well, that's the first option, projection. Projection. Option number 2, eclipse glasses. Eclipse glasses. Perfect. Great way to do it. Okay, absolutely great way to look at the sun safely, as long as they meet certain requirements. Now, back in 2017, there were stories of counterfeit sunglasses being sold. You don't want to buy these things from an unknown source, from a source that you don't know is reputable. You don't want to buy it from eBay, for instance. I wouldn't necessarily want to buy it from Amazon unless I know that the company is one of these reputable manufacturers. I wouldn't want to buy it from Temu either. You want to make sure, first off, they're made of reflective mylar or some other energy absorbing material. The idea is this material is designed to reduce the dangerous rays, ultraviolet, infrared, and visible light down to a safe level, reducing it by a factor of something like 99.9999999 some percent. Okay. How do you know? Well, the International Standardization Organization, ISO, has a standard now, 12312-2. You want to make sure you read that someplace on either on the glasses or in the certification that came with the glasses. It's got to say ISO 12312-2. It's got to say that. But at the same time, I'd also be concerned for counterfeit or suspect items unless I purchase this from a reputable manufacturer, such as, and I give you a very short list here, but American Paper Optics have been doing this for years. Celestron has been around for decades. Daystar Filters has been around for decades. Likewise, the rest of them here. Explore Scientific, My Astronomy Shop is affiliated with Astronomy Magazine, Rainbow Scientific, Thousand Oaks Optical. There are others as well, but these immediately pop up. So those are the names of the companies you're looking for. Now, if you want to see a much more comprehensive list than I'm giving you here, go to the American Astronomical Society's professional organization. Okay? Go over to their Eclipse listing over again. It's in the resource guide. And they'll have a comprehensive list, not just of manufacturers, but also distributors. So I just ordered, in fact, filters for myself, my family, my camera from their Celestron filters. I bought them from a company called High Point Optics in New Jersey, and they've been a deal that's been around for decades as well. And I'm due to get them tomorrow, I think it is. So you want to make sure that you get, again, it has to be ISO certified and from a reputable manufacturer, really key, and a reputable dealer as well. So we have Eclipse glasses that you can put little cardboard glasses you could put on. There are Eclipse cards that you can hold up in front of your eyes. That gets a little bit tiring after a while, I would think, with your arms. But the glasses are probably a little bit easier to use. Um, Celestron also makes, this is interesting, it's actually a little mini binocular. You have to hold them in front. Okay, you don't wear them like glasses, but they actually will magnify the view 2 times, so it makes it a little bit larger. There are also dedicated solar binoculars. This happens to come from Celestron also, but other companies as well have been offering these things, and they're fine as well. Understand if you want to invest the money into binoculars, they are only suitable for looking at the sun. You can't use them for birding or any other activity because the filters are permanently installed, and you can see them right in the very, very front over here. Okay. So you want to make sure that, if you're going to be using, if you're going to put money in for solar binoculars, understand what their limitations are just for the sun. Again, though, make sure the ISO standard is met. Now, let's talk about some fake news regarding Eclipse glasses and cards. Some glasses and some of these solar glasses and viewers are printed with warnings saying that you shouldn't look through them for more than 3 minutes at a time, and that you should discard them if they are more than 3 years old. Okay? That's nonsense. I don't know where this comes from. Okay, I don't know. It's online. Oh, it's online, so it has to be real. No, it's fake. Okay, fake news. These warnings are outdated and don't apply to any of the Eclipse viewers that we just looked at that are complying with this ISO 12312-2 standard, and assuming they're in excellent condition. You want to store them safely. You don't want to just throw them aside. Okay, you want to store them safely. Put them in a Ziploc baggie would be fine. I'd probably maybe evacuate the air, make it a little bit drier in there, but that's perfectly fine. But you don't want to use them as coasters to put your coffee mug on. Okay, things like that. No, treat them. I mean, it's not that they are incredibly delicate. They're just cardboard, for the most part. So you don't want to, you don't want to beat up cardboard too much. As far as you should only look at the sun for no more than 3 minutes at a time, that's nonsense. Okay, you can look at the uneclipsed sun, in other words, on any clear day, or a partially eclipsed sun through these for as long as you want. You can watch it from sunrise to sunset every day of your life, and your eyesight will be no more negatively affected than if you stay in the dark closet hiding from the sun every day of your life. Okay? They're perfectly safe to use for as long as you want. Now, there is a trick. You don't want to necessarily be looking at the sun and then put the glasses on if you're using the viewing glasses. You don't want to do that. You probably want to turn away from the sun, then put them on. Okay. If you wear eyeglasses like I am, you could ideally want to put them in front of your eyeglasses. Okay, ideally, that's so, because you don't want the eyeglasses to get hot from looking at the sun. So the filters have to be the first thing, because they're going to filter not just the light, but also the heat. And that's going to make a more comfortable experience on many levels. Okay. Any questions about that, by the way, about this? I just want to make sure that we're all clear with this.
Thanks
Okay.
for clearing that up, Phil.
Okay. I want to make sure that we're all, because this eclipse coming up in April, it's going to be spectacular, especially if you see this total eclipse. But even a partial eclipse, it sucked me in back in 1970. Can be spectacular. The last thing I want people to come away with is they're afraid that this is a bad thing. Okay.
Yeah, that was good information. We had a library system who saved a bunch of glasses from the previous eclipse and distributed them. So previous information made us nervous. So now
Well,
you can rest assured that those are fine.
Yeah, I have some from last eclipse also. I'm going to use them. Now I bought 10 new ones. They're coming on Saturday, because now I have 2 grandchildren that are going to be able to use them, and my wife and daughter and son-in-law and so forth. So I have 10, all together. But I still have the old ones I have a sun filter still from 1973 that I bought for a telescope back then. I would use that today. Okay, so but you first check it. If you have any concerns, you hold it up to a bright light, not the sun. Okay, a bright light. And if you hold it up to a bright light And if you can see the light coming through, even faintly, or if you see pinholes in the filter, because it is pretty thin material, you see pinholes, I wouldn't use it. Okay, I wouldn't use that. But short of that, I think it'll be fine. Mary Carol, you have your hand raised
Yeah,
here?
yeah, Phil, I just want to mention I had ordered a bunch of Eclipse glasses from the Astronomical League,
Hmm.
and we have Drew from the Copernic Observatory here with us today, and they're also selling them. And then one of our future speakers, who's one of the NASA ambassadors, has a bunch obtained, I think, through Rainbow that he will
Okay.
also be selling. And I
Hmm.
think Drew's gonna put the link in for the Copernic one. But yeah, some of the astronomical societies do get glasses from reputable
Right,
manufacturers.
right. Yeah, as long as there were some concerns. I read stories. I don't know anybody personally involved, but of counterfeit ones being sold. It could have been stamped with the ISO number and so forth, and yet they were fake. And that's why you have to get it from a reputable source. You have to know the source. Don't buy it from eBay. Don't buy it from Amazon unless you know the source. That's the best I can offer you. Okay, moving on. How about for cameras and binoculars? Same thing, same basic precautions over here. I will tell you that these two companies, Daystar and Celestron, have come up this year. In fact, they came out just earlier this month, or maybe very late January. Have come up with these two universal lens filters. These are pretty cool. In each case, they are designed specifically to fit over the front of a camera. They could be used for binoculars also, I assume, because they're both for photographic as well as visual use. But they fit over, for that matter, even a telescope, small telescope. They fit over the front. You want to make sure the lens goes over the front optic. Okay, you don't put, I'm sorry, the filter rather goes over the front optic, the front lens. You don't put the filter behind the front lens. Okay, it always goes in front of the front lens. That's critical for all of these. Okay. I just picked up one of the Celestron ones, and I expected on Saturday to use with my camera. But the idea is you put them together, a little cardboard, very inexpensive, less than $20, and you fold them up like a box, and then you use a rubber band or Velcro or some such thing to hold it in place. And they work very well, or at least I expect them to, from what I've seen online. I'm going to test out the Celestron one on Saturday when I get it. But it's another option. Again, reputable sources. As far as telescopes, I'm just going to keep repeating myself. There's a photograph taken of the sun through a filter that I had some years ago now. But the sun is now properly filtered down. That is to say, the intensity of the energy properly filtered down so we can look at it safely and have a perfectly nice time. One thing you don't want to do, this is important, you never, ever, ever want to use a sun filter that screws onto the eyepiece of the telescope. That's to say, the eyepiece is the lens that you look through at the back of the telescope. You never do that. They used to be supplied with every telescope made back in the 60s and 70s, including the first one I got back in 1968. It would screw on. Okay. The problem there is, you see, the telescope, of course, is going to gather light from the sun. It's going to magnify it, and it's going to then bring it to a focus or concentrate. Well, as a kid, you ever take a magnifying glass and let the sun pass through the magnifying glass onto, say, a dry leaf or a piece of tissue paper? What would happen? The leaf or the paper would start to smolder. Well, the exact same telescope's doing the exact same thing, but not by a factor, maybe a magnification of 2 or 3. No, we're talking about 100 power, maybe. And so it's going to focus that light very, very precisely onto that glass filter. And what's the glass filter going to do? It's going to crack. Okay, it's going to crack. And then the unfiltered sunlight blasts you right in your eyes. Okay. I had something similar to happen to me when I was, let me think now, I was about 12 years old. First telescope. Had one of these. Okay. I screwed it in and I would look at the sun. And it was nice, pretty, the orangish colors you see here. That's the sun's not orange, but that's just the color the filter produces. And then one thing I noticed every now and then, looking at the sun, I would see a bright flash of light. And I thought, well, I was a 12-year-old kid. What do I know? Just reading books. I thought, wow, I'm seeing a solar flare. Yeah, I'm seeing a solar flare, all right. A hairline crack in the filter had developed. And so every now and then, as the sun was moving across the field, the light from the sun would go through that little crack. And I see that flash. I'm really lucky that the filter didn't crack entirely and the sun just blasted me in my right eye. Okay, I'm really lucky. So these things are a big old fat no-no. Now, manufacturers have stopped selling those decades ago. But as I was preparing this talk, I wanted to find an illustration of one of these filters, like you just saw there in the picture here. I found it online, of course. But I found it online because I actually discovered that these things are still being sold on Amazon and especially on eBay. I can't believe it. I can't believe it. They are dangerous. Absolutely. So you never use an eyepiece filter. Very, very bad. If you have one in your collection or you know somebody who has one, take it, throw it away. Okay? You never, ever want to use it. What you do want to use is like this filter. It fits in front of the telescope. Perfect. Again, you're filtering out all the high intensity energy before it enters the optical system. That's what you want to do. Inside the telescope, it's nice and cool. Light comes through, comes to a focus into your eye is happy, the telescope is happy, it all works. So you want to make sure it's mounted securely. They are. They come with various ways of securing them in place. And you want to do that. Again, looking at the partial, this is all for the partial phases. Okay, partial phases. Again, only reputable brands. Just a short list here. You recognize some Bader Planetarium is in Germany. They manufacture a solar filter material, which is considered to be, at least by some people, the best quality. A lot of companies use this Bader Planetarium filter material for their filters. So if you ever see that name, Bader, B-A-A-D, I think that's how you pronounce it. That's how I pronounce it. But if you ever see that, it's good stuff. Okay, that filter material is very, very good. Now, any questions about filtering at all? Real quickly about photographing. Any questions all about proper filtrations? What's good, what's bad? Anything at all? No? Okay. Let's talk about photography. Okay. Most people who go to look at an eclipse want to preserve it as a memory to share with others. And I'm right there with you. Okay, I really am. Photographing an eclipse is very easy to do. It's very safe to do with the proper filters and so forth. You could use a smartphone. You could use a digital camera and so forth. But there are some tricks to learn so that you don't blow the eclipse trying to photograph it and then you don't see it. Okay, the worst thing you could do is to try to photograph an eclipse. The pictures come out lousy, and because you are so focused, no pun intended, on imaging the eclipse, you never looked up at it. Worst thing you can do. So therefore, the 3 Ps, practice, practice, practice. You want to get your equipment up and running weeks before. Now's the time to do it. Don't wait till April. It's the end of February already. Now's the time to do it. If you want to buy a filter, get it right away. Okay, they're going to run short on them as you get closer to the eclipse, I can guarantee you. Get a filter that'll fit your smartphone camera. Get a filter that'll fit the lens of your digital camera if you want, whatever it is. Okay? Regardless, you want to make sure the camera or phone, I'm not going to keep singling out smartphones, but I'm going to at least use the term camera more generically now. You want to make sure the camera's on a tripod. You don't want to hand hold it. Okay? You don't want to be fussing around with that. Have it on tripod. Okay, that's number one. If your camera allows it, you want to use manual settings. You're going to find that automatic exposure does not work well for this. And the reason is, you see it especially with the partial phases, because with a filter in place, you have the sun, which would be a circle in the middle of it, surrounded by black. Well, the brain of the camera is going to think, wait a minute, I have mostly black. That means I really have to up the exposure. And so it's going to completely overexpose your image. Okay, so you want to use manual settings if the camera allows it. If the camera allows it. You want to test all this out. Photograph the sun after you get the equipment all set up. Photograph the sun on a sunny day. If you have the equipment, do it the next sunny day. For the next sunny day, you have all the equipment in place. Set it up, test it out. Okay? Make sure the filter is in place, and you want to play with the exposures or bracket the exposures, as they say, starting with the shortest exposure right up to the fastest exposure. Play around with if it's a zoom lens, play around with the zoom setting, play around with the f-stop settings, everything. Okay? You want to do that. You also want to double check that you get a good focus. Here's the problem also. You're going to find out, you may already know this, autofocus is great as long as you're taking pictures of a daytime scene. Okay? Once you get into dim lighting conditions, though, and remember, even though it's going to be a sunny day out, we hope, for the eclipse, you have that filter on. And so the camera's brain thinks, uh-oh, nighttime, because this image is going to be so dim. And so during low light conditions, autofocus doesn't work at all. It doesn't work at all. So you want to set autofocus off. You want to go to manual focus. A good way of doing it, forget even the sun. You could do this without even the sun filter on. You don't need it because you're going to photograph the moon. It's coming up to full moon right now. Okay. Photograph the moon at night to get a sharp focus. Okay. That is the best way to do it. And once you know where the sharpest focus is on your camera lens, again, you're using the manual adjustment back and forth for this, make a little mark. Scratch the black if it's black, do a little mark. You don't want to mar it necessarily, but just a little indication where it is so that when the eclipse comes, hey, I know I'm going to set the focus right over here. That's what, so test, test, test. That's the beauty of digital. You get instant gratification. You can look immediately, oh, that is in focus, that's not in focus. Back in the day with film, it would take you days to get results back, if not weeks. And then you have to do it all over again. And that was a real time-consuming and very expensive proposition. So you want to do it and look at it right away. Oh, and also, if your camera has an automatic flash, and smartphones have this, and some digital do also, but you want to shut off your flash. Okay, last thing you want is flashes going off in the middle of an eclipse, but it has happened. Okay, so you don't want to do that. So make sure that the flash is disabled. Always make sure that the filter is on before and during the partial phases. Now, if you're going to see the total eclipse, you got to make sure you take the filter off before totality. Okay, totality is when the moon's disk completely blocks the sun's photosphere, which is what we're looking at in this photo I took of a partial eclipse. Okay, you want to make sure that the filter is off. If you keep the filter on, you're going to have a lot of blank pictures because the corona is way, way too dim to make it through the filter. So you want to make sure the filter is off. Maybe 20, 30 seconds before totality begins. Okay, maybe something like that. I say maybe because it's really hard to gauge it. Okay. But you want to have, and they make apps for these, eclipse timing apps. From your location using your phone's GPS, it's going to tell you totality in 1 minute, totality in 30 seconds. It's going to give you a countdown. So use that. That's really to your advantage. You want to set your film speed to a value about anywhere from ISO 100 to 200. The higher the ISO value, the quote unquote faster the speed, and so you need shorter exposures. I would probably go 1 to 200. You get better resolution with that. Anything faster, and your resolution may suffer a little bit. The images look a little bit grainier, and won't have quite the aesthetic appeal. But you want to vary your exposures dramatically. Okay? You want to change exposures all over the place. You want to run the gambit of your camera's exposures from, I wouldn't go 30 seconds necessarily, but my camera goes up to, I think it's 30 seconds. I probably go from 1 second all the way down to something like 1/10,000th of a second. I think it's the fastest. I'm going to go the whole range because every exposure is going to record a different aspect of the event, of totality. This is especially true with totality now. Okay? Different aspect of it. There are some pieces of software, Photoshop, for instance, is one, that you could take the individual frames and then stack them. And you get a single image which shows the full dynamic range of the eclipse. Those images are gorgeous. They're way beyond my abilities, but they are gorgeous, showing all these fine details. So again, play around with it. For the beginning and ending of totality, you talk about exposures from 1/1000th to 1/4000th of a second. Okay, because you're gonna have the sun coming through. A little bit of the sun. You don't want to look at it necessarily, but your camera's okay to look at it briefly. And so you want to take those pictures. Longer exposure, if you want to record the corona anywhere from 1/4 of a second up to about 1 second long. Shorter exposure for prominences and such along the edge, from 1/100th to 1/1000th of a second is probably a pretty good bet also. Something like this, as we're getting into it, very, very thin crescent. Then here we have some sunlight coming through, but that's the very beginning of totality. And you can see a little bit, you get a little bit of the corona coming through over here, a little bit of the prominences over here, but that's still sunlight just coming through toward toward the beginning of totality. This is key. On eclipse day, most importantly, don't forget to watch it. I said before, the saddest stories I'll hear are people who say, I was so busy photographing the eclipse, I forgot to look up. That's the saddest thing. Okay. You want to plan things out. You want to say, okay, I'm going to allow this much time for photography, that much time to look at it. You know, again, I'm talking mainly for the total eclipse. Partial eclipses, that's pretty slow. Okay. But you have only so few minutes for totality. You want to time it out so you know exactly what you're doing. It'll be the most spectacular thing you've ever seen. Promise you. Well, let's wrap things up with the completing panel for that series that was from back in 1963 with Peanuts. You see Lucy walking out on eclipse day, walking out of her home, walking across like so, and she finally finds her brother Linus outside with his solar projector, and she looks up in the rain and says, "So how's the eclipse?" That's the last thing we want. You don't want to become Lucy or Linus. I don't want to become Lucy or Linus, certainly. But what if, okay, what if it is cloudy? What can you do? Well, there are several sources. I know of these three right now that will be webcasting live events of the eclipse. Exploratorium, which is based in San Francisco, although they won't be in San Francisco, they'll have stations around. NASA will. Also, time and dates, an excellent website for this sort of information. We'll have live streaming events. Worst comes to worst, you look at it online. Okay. It's not terribly satisfying, but we do the best we can do. But I will tell you, that doesn't mean you should stay inside necessarily, because even if it is overcast, it's still going to get very dark. If you, the closer you get to the maximum eclipse, especially the closer you are to the path of totality, if you're inside the path of totality, you're going to notice, even if it is cloudy, the wind's going to change. You're going to notice the temperature drop. Pay attention to the wildlife. Pay attention to the birds, especially. They think it's nighttime. They're going to go to roost. They make a lot of noise when they're doing this. For them, nighttime is going to last about 3 minutes. And then it's suddenly going to get brighter again, even with the clouds. It's going to get brighter again. Those poor little things there think, geez, that was the shortest night I ever saw. And then the day picks up again, starts to get brighter, the temperature goes back up and so forth. So even if it is completely overcast, it's going to be a memorable event. Absolutely. Absolutely. I really do hope you get a chance to enjoy this eclipse. Okay? I hope you have perfectly clear skies where you are in the path of totality or seeing a partial eclipse. And it's going to be something that you're going to remember for the rest of your life. Believe me. Thank you very much.
Thanks, Phil. We're wishing you clear skies as well. So we had a lot of great questions submitted in advance, and I know you took care to include all of those within your presentation. So thanks so much for that. But we do have another minute if anybody has questions that they want to put into the chat. And I see there was a couple of photography tips just shared, and another resource from Copernic Observatory shared there as well. I also put in a brief webinar survey link there for you. And I would like to invite everybody to the next webinar in the series. It's on eclipse soundscapes and dark skies. And that is going to be on Monday, March 4th from 3 to 4 p.m. So any last questions for Phil?
If I could add one thing, the next eclipse total eclipse across the U.S. is going to be in August 2045. Okay. I'll be 80, however many, I don't want to even think about it. But you know what that one is? That's going to go right over Disney World. That and the Kennedy Space Center. Can you imagine what Disney's going to charge? But anyway, that's going to be the great Walt Disney World eclipse. It's coming up in August of 2045. That'll be the next one.
And Phil, if I'm not mistaken, and maybe I could be, but the next one that would be visible from this area would be May 1st of 2079.
Right. That one right over here. That's an interesting eclipse because you see the center line, it goes right over Long Island. It goes right over my backyard, the center line. right over my backyard.
Our
I'm going to be
children
100.
will,
I'm going to be 123 years old.
yeah, our
Okay.
children will be in their 80s and
There,
90s.
yeah, I know. Yeah.
Sobering thought.
Yep.
I was
And it's going to,
also just,
I'm sorry, it's going to be a sunrise eclipse. That's going to be some sight.
wow. I was just looking at Richard's comment. A lot of cameras have automatic timer modes, which you can set to take pictures at certain intervals.
That's true. They have intervalometers, some of
Also,
the advanced cameras. That's true.
yeah, okay.
Yeah, and somebody mentioned they had that warning on their glasses, so thank you for clearing that up. All right, well, thanks again, Phil, and thanks everyone for joining us, and I hope you all have a good afternoon. Take care.
Clear skies, everybody. Thank you.